Hi, this is Patrick Sweeney from ODIN, coming to you today from the beautiful French Alps. We're at Les Ouches d'Hiver, the site of the 2011 Men's World Cup Downhill. Now you might be wondering, what does Men's World Cup Downhill skiing have to do with RFID? Well, there are two very important aspects: speed and accuracy. Both are required for a world champion downhill skier, and both are required for a world champion grade RFID system. Let's talk about speed first. One of the things people realized going back a couple years was that traditional middleware, which sat in a network operations center or data center someplace, giving commands out to readers that were on the edge of the network, had latency issues and command device control issues. For instance, if you read and interrogated a tag at a read zone, what would happen is the reader would have to send a message back to the server in that data center and get a command before it could take an action, like lock a door, like set an alarm off, or like take a picture. So that latency and the speed with which the RFID reader could respond created a lot of problems for early RFID deployments. The solution became to put intelligence on the reader. So an RFID operating system became critical, and we'll see an example of that in just a minute. The second component, accuracy. The only way to get accuracy from an RFID reader is with physics. And with physics, you're able to get 100% accuracy if you're using all the command functions deeply embedded in the RFID firmware. Again, the only way to really do that is to embed an agent or an operating system on the firmware, and that allows you to have great control. Let's go out on the slope, since we're in the skiing capital of the world, and take a look at exactly how an RFID operating system can solve the problem of speed. Speed is critical in an RFID network, particularly at the interrogation zones. One of the reasons traditional middleware has failed in a lot of instances is oftentimes an RFID read point takes place right at a critical exit, entrance, or something that has to be triggered, say for instance a red light or green light. Part of the problem with traditional RFID middleware is that when something gets read, it has to deal with network latency to get back to where the server is. Now, if I'm the action, and I'm going to give action to close the door, to set off an alarm, to make a GPIO signal turn a light red, green, or yellow, that read event has to happen, take place, come back to me on the network. If there's a threat, as you can see there, I've got to make my way. Where speed becomes critical, and why RFID systems are so successful that have embedded RFID operating systems, is right at the point of origin. As soon as you get a read, you can take some sort of action. So having an operating system like EasyEdge on your RFID reader allows you to take a read event, and as soon as there's a threat or an action required, you can deal with that action immediately. There's no latency between the two events.